We're live on Twitch from WDB. This is edition 2 of Remote Python Island. Welcome. Yay.
Hello.
Well, again, this is Nicolas, everyone, and Chuck from DB. Again, thank you very much. Thank you very much for hosting. Hello. And yes, this is edition 2. I'm so excited to be here, guys. Thank you very much for everyone that is here with us as well. Oh, Stefan, hello. And yes, Agatha said hello as well. And everyone that is saying hello in the chat. And perfect. So we shall start then. And so let me share my screen. Perfect. So here we go. And wonderful. So Twitter and email, if you guys want to talk to us. Then if you would like to send us a message on Telegram as well, please. Then the plan for today, then folks, will be, I have a little bit of some news for you, very basic stuff. Then we have lovely Nicolas Demarchi over here. With a talk on how to create your own streaming torrent client with Python. We shall tell you that this is for learning purposes only, right? No piracy on this meetup. Then after that, we'll have a Q&A session. Ooh, we have someone else joining us. Then after that, we have Dr. Hayley Evers-King with a talk on plankton, polar orbiters, and Python. So yes, she gave a talk a few months ago on coloring with Python. It was quite interesting as well. So the colors of the oceans with Python, and I'm really looking forward for that one as well. And then at 20 past.
Donc ça te filme toujours en contre-plongée comme ça te donne un air de super méchant.
Sorry, just 1 second. Thank you. Perfect. And then at 20 past 8, we will have our session of lightning talks. So if you have a lightning talk that you would like to share with us, I will put the link for the Google Forms on the chat in a few minutes. And we would love if you would like to submit your talk. The only criteria for the lightning talks is that they're 5 minutes and they can be about whatever you want to talk about. And then after that, if you have nothing else to do, then you'll be doing your closing ceremony. So yes, let's start. So on the Did You Know today, I chose to talk about Mrs. Evelyn Boyd Granville. So she had 2 PhDs. She's an American mathematician. She was the second female African-American to get a PhD in maths from an American university. Then after that, she got another PhD from the Yale University, also in America. And later on, she joined the US Space Tech Labs to study rocket trajectories and orbit computations. And then for the last 30 years of her career, she decided to go back to teaching and dedicate the rest of her career just to teach women and educate women in technology, which is quite big, especially for 1967. Then our Python announcements. So the next Python Island remote meetup so far is going to be on the 13th of April. As usual, 13th of May. Sorry, that's a mistake over there. As usual, we're keeping it for the second Wednesday of each month. And so, yeah, just keep an eye on our Python Island webpage, the meetup page, and we have some good talks lined up for you as well. Then EuroPyCon, we opened the ticket sales yesterday. So if you're thinking about showing up, I would say run and grab your tickets as soon as possible. Then, we are gonna start our talks. So Nico, I will pass the microphone now to Nico. Nico is a host for Python Amsterdam. He is from Argentina, not from Buenos Aires, but from Argentina. He has done a little bit of everything in his life, but mostly with computers. And recently he moved to Amsterdam to work in Optiver, having worked with Satellogic before, building spaceships using Python. Python in space! He's an active member of the Python Argentina community and also a host for Amsterdam right now. So welcome, Nico.
Hello, thank you. So let me try to share my screen and see if this one works. Okay, just a second because I want to see the chat. So cool. So I will have the chat here so you can write to me. So usually I have a problem that I'm quite fast speaking, and so if I'm going really fast, please ping, take send a heads ups in the chat. Okay, let's start. Is my audio okay? Is everyone listening? Is that working? Cool. So this talk is about how to create your own streaming torrent client with Python, of course, for learning purposes. Before starting, I was just to mention today, Marcos Munstock diet. So farewell. This guy was part of the Les Lelutier. That was an Argentinian comedian group, a really good one. And the reason I'm mentioning is for the Python community in there, this group is quite important. So I would say if Guido van Rossum was Argentinian, we will be all coding in Luthier, because I think Le Luthier was a really nice equivalent for Monty Pythons. So farewell, Marcos, we will miss you. Then a bit about me. I already have a really nice introduction for life. But so I'm Nico. Everyone knows me as Gilgamesh, also Gilgamesh. I'm from Venado Tuerto. Is that place in the map. I added the map because so we're in Europe. Europe is small. So when I'm saying I'm from a town, it's not 10 minutes. So it's 5 hours or 4 hours and a half by car. And that's, if you compare with Europe, it's like from Amsterdam to Paris. So to give you an idea. So that's a small place in the center of Argentina. And as Liza already said, I am a member of the Python Argentina community, and I'm currently also a member of the Py Amsterdam. We are hosting a meetup here in Amsterdam. In the last month, we are hosting that meetup online. If you want to participate there as a speaker, or if you want to join the meetup, just go to the website. Tomorrow at 7 p.m. Amsterdam time, it's 1 hour difference with Dublin. We have a meetup. And then a disclaimer. So first of all, this talk is a rehash of a talk I gave with Felipe in 2014. So I had to translate the slides, read the code, and I did a fast version of this one in Python 3 because I wanted to force myself to learn how it works. So probably, if you read the code that you wrote, like probably, I don't know, 6 months ago, a year ago, you say, oh, who wrote this thing? It's horrible. So thinking myself reading a code I wrote 6 years ago, that was my feeling. So I don't want to have a philosophical discussion about torrent or piracy. I want to discuss more the tech part. It's a part that is a lot of fun for me. And in particular, I think that torrent will be an amazing tool for video on demand using open source software. So that's the idea. We can share a beer and talk about the philosophical part, or I'm happy to do that if you want. So let's start first with an introduction. So sorry if you're an expert in torrent, maybe it's going to be not new for you, but I wanted to have everyone in the same channel. So what's a BitTorrent? BitTorrent is a decentralized protocol for file sharing. It's well known as peer-to-peer, P2P. in this protocol, each client is a peer that connects to a tracker. A tracker is a server that you can connect. And in that tracker, you can find other peers. And then from those other peers, you can download parts, chunks, pieces of a torrent that you want to download. So it's like you can go to a place and then you can interchange things with your friends. If you want to create a file, a torrent file to share, so you want to share a picture or a zip file or a video or whatever you want to share, you have to create a torrent file. And in that file, you will put all the information for other peers to be able to download your file. So that's the most important part, is the hash value. Of course, you have the size, the file name, the IP address of a tracker. So the tracker is like the place that you can go to find other peers, and the size of the pieces. There is for sure more data, but that's basically what's there. And then a torrent is a file, but that file you need to download it from the internet. And there is a different version. There is a magnet link, and a magnet link is a URL. So it's a URI that you can just send that in a message or in an email, or you can have the link in the internet. So you don't need to store the file or to download it. So that's really good, because you don't need a centralized server where you need to put all the files and download those files. So with a magnet, you can get all the information to ask the other peers the data to download the torrent, so they can give you the torrent. And then each torrent has a unique 20-byte SHA identifier. So that's quite important, because that's what we use to find a particular file. Then other part of the torrent is a peer. So a peer is a client, it's you. But technically, a peer is an instance of a BitTorrent client. So then a peer can upload or download data. It can send or receive data. It's not only uploading and downloading, it also can send metadata. And for peers, you can see we have some slang. So you have like seeders and leechers. A seed is a peer with 100% of the pieces. And then a leech is a peer with less than 100. So a seed is usually, the name seed is because probably the first one, but it could be also more. And finally, I already named it, you have the tracker. So the tracker is a place that you connect, is the place that you go to get the initial list of other peers that are sharing the same file. So when you connect to a tracker, you announce in that tracker that you are ready to interchange a torrent, and you are also announcing which pieces you have for that one. So I'm a seeder, or I have only 10 pieces, I have none, or I have half, etc. And the tracker is the entry point to a swarm. So a swarm is the torrent community. It's a community of peers that are interchanging files. And the tracker is your key to go there. It's like someone telling you the secret name of a secret place for a party. In the last years, it's possible to skip the tracker using DHT. That's a decentralized hash table. So basically, it's when you connect to a tracker, you ask the tracker for the list of peers for a particular file. And the DHT is a protocol that means that if you know one peer, you can ask that peer about the others, and it will give you the data. So then you don't need a tracker. So because if you see the torrent protocol, the tracker is the central point of failure. So if you kill the tracker, then there is no sharing. And then a piece. What's a piece? A piece is a chunk of a file. It's a small part for a file. So it's exchange unit of a torrent file. So when you are sharing, you are sending or receiving pieces. When you download a torrent file, or when you get a torrent file using a magnet, one of the things that you have there is all the pieces, the number of pieces, the size of those pieces, and also a show one of those pieces. Usually they have a common size of 64 kilobytes or 4 megabytes. And I already saw they have a show one for identifier. So cut to the chase. Let's start with the history. We have all the parts. We have a high level idea of what's Torrent doing. So let's try to move. Let's try to build our client to see how we can do it with Python. So first you need to get a magnet. So because I prefer magnets, I don't want to download the torrent file because I don't trust other websites. I probably trust more the peers. So this slide is now from 2014. It's a new one. I did a quick search in the internet, and the most popular torrent tracker site seems to be this one. Of course, there is a library. So thank you, Harshanas. As you can see, this is a small screenshot of the README. It's quite trivial to use it. So you need an instance of this client, and then you search, and it will return to you a list of magnet links with some extra metadata. So then you have the magnet. That was easy. Next step is, okay, I have a magnet, how I download the torrent. So of course you can use existing torrent, yeah, but then we want to write our own. So with Python, you can use libtorent. Libtorent is a BitTorrent C++ implementation. I think it's the most common one. It's used by a lot of different clients. It has a focus on performance and usability. It has really good documentation. For me, at the beginning, it was a bit harder because it's more in the C++ world documentation, but it's really good. They have really good data there. And it has a Python binding. So it's a C++ library, but we can use it from Python. That's awesome. So you have all the nice features of this fast library from Python. As I already say, it's easy to use. And you can use it in any operating system. You can run it in Windows or Linux or Macintosh, probably Android, I don't know. I'm sure there is a version there. I wrote this small example to show you how easy it is to download. So it's like less than 10 lines. Yeah, with the spaces is 13. So I wrote this function download. So you receive a magnet. Then you prepare some parameters. To be honest, the line 7, we can remove that one because in the past it was not the default, but now it's the default for the library. So it's a line that we can remove. That's the storage mode. That means that how the libtorrent is going to reserve the space in your disk. So in the sparse mode, it's going the file is going to be growing. And if in the other mode, it's going to reserve, like if you're going to download a 1 gigabit file, it's going to reserve a full gigabit, and then it will be filling it. At the end, the URL, you have to create a session. So this is a libtorrent session. I want to explain now what's it. And then you have this add torrent function that you call with these parameters. So basically you say, I want to save the file in this path, and this is the magnet, and it will start downloading. The session, it has a loop that manages all the downloads. So you can add more than one torrent, and for each torrent that you add, it will return a handle to you. So with that handle, you will be able to check the status and to control, etc. And then in this example, I did a really single thing. It's like, okay, a while. If I'm not a seeder, so that means if I'm a seeder, that means I have the 100% of the file. So if I'm not a seeder, that means I'm still downloading. So if I'm not a seeder, I will print downloading. Yeah, that was easy. So I was saying a session is an instance of libtorrent. It has a main loop, so it has like an event loop, and you can add a lot of torrent, and it will take care of the download. For each one, you have a handle. That handle is important because you can use that to check what's the current status of your file. And inside the handle, you have a status that has a lot of information. So I will give you a few tips that with this small list, you can probably do a quick test, like in an IPython shell, and then see what's happening. So in the handle, you have a status, and in the status, you have pieces. So in pieces, libtorrent is going to return to you a bit mask representing all the pieces with a state. So let's say our file has our torrent, it has 10 pieces. So it will be a bit max of 10. And in each position, it will be true. The value will be true if the piece was downloaded. So you can check if piece in position 4. If that's true, that means that you downloaded that one. And then you have a get and set for priority in the handle. So you can change the priority for one piece in particular. That's quite important. I will explain later why. And in the state you can also check the download queue. Download queue is not for different torrents. It's for the queues. It's for the queue for one torrent. So the libtorrent is adding pieces to the download queue, and you can query which ones are currently in download status. That's also really important. So I don't know, sorry if the code is not really easy to see, but probably you can read it, but oh, sorry. So then this is an example of I was saying. So you can query, give me the download queue, and then for each piece, I will make a list of the ones that are currently downloading. Then you can get the list of all the pieces. And what we are doing here is that we are iterating the full list. And for each one, we say, okay, if piece, so if the piece is true, that means I already downloaded that one. I will put a numeral, a hash in green. If it is not true, I will put that one in red. So we know green ones, we already downloaded, red ones, we are downloading it. And then if my piece is in the listing of the downloading, I will put that one in yellow. So that means it's currently downloading. I'm also adding the priority here to the after the numeral. So that's quite easy to see. And what I'm showing it is because this bit mask is not easy to see, but in Python it was trivial to configure a download progress bar. There is some extra code here that is not so relevant, but then if server block is related with streaming, I will explain later what's that, but then it will put in blue if someone is requesting that part of the file. So the name of the function is the frag because it was maybe I'm old enough to have experience with Windows 98 or 95, and you have the frag for your list, and with the small squares that were changing. So that's the reason for the name. But then what I wanted to show here is that with libtorrent, you have a really simple function to download, and then this code I think is still probably too complex, and it has some Python 2 format somewhere, but it could be simpler. But then you can have like a visualization, like a representation of what you are doing. So let's talk now about strategy. I will explain first what's the PS speaker, and then I will say why this thing is really important and why the priority is important. So the PS speaker is a component of the libtorrent who manage which pieces are going to be in the download queue. So it has a queue, and it is telling, okay, I want to download the piece number 5, I want to download the piece number 10, etc. And it has a strategy to pick which one is going to be next in the download queue. That strategy by default is the rare first. So the rarest piece in the whole file, in the swarm, so the piece that no one has, or maybe only one person, that piece is going to have the highest priority. And in that way, Torrent is helping the swarm, is being friendly with the swarm. So we have all the pieces available full time. Because if I'm the only one with this as a seeder and I disconnect, maybe everyone has a part of my file, but then I disconnect and it's not possible to you to have the full thing. Then for each piece, you can have a priority from 1 to 7. 7 is the highest. And it's also possible to set a deadline. And with those both options, you can affect when the piece picker is going to add a piece to the download queue. And really important, this is not in the docs. If you set a deadline really, really low, it will download the file ASAP. So why this part is important? So in 2014, when I started this project, so this was like a 2 weekends of fun with a friend, and we were saying, oh, we can do this, and we started playing with that. I think popcorn was really popular. And then I found that this popcorn software was using a sequential way to download. So why? Because I was saying at the beginning that I wanted to do video on demand with torrent. So that means that we are going to download the torrent and watch it at the same time. That means that if you use the rare first, the most common thing that is going to happen, let's see, I don't know, Python Ireland is publishing a torrent with the MeetUp video, and everyone in the internet wants to watch that video because it's really popular. Then if you use the sequential download, that means that everyone is going to start watching the video and everyone is going to have the first part. But then if I am the only seeder and then at the half of the video I disconnect, no one is going to have the last part. And then no one is going to see the end of the history or the end of this talk. And that's really bad. So that means that this popcorn was not being friendly with the community. And you need to find a way to be friendly, but still have the option to watch the video. Because if I use only the rare first, then my libtorrent is probably going to download first the last part because it's the less common part. And then I need to wait, and to be honest, internet is quite fast now, but probably not a lot of time. But let's see, we have a 4K version of 10 gigabytes. So you will need to wait a lot. So this video, can you see the video? Is that working? Cool. So this is an example of how the strategy for Touch and Go was working. So it is trying to download the first 4 pieces, setting the priority to 7, so the highest priority. And then if you are watching a video and you need to stream that video using HTTP, for a video you need a thing that name is move, it's MOOV. That's basically an index. So a video is frames. So it's a lot of pictures with an index. And your player, if you use VLC or any player, it needs this index to be able to reproduce the video. And there is 2 options to have this index. You can have the whole file, and then yes, I have all the frames. Or the other option is that you have the index and you say, okay, I can start playing this frame. This is the first frame, and this is the speed I need to play these frames. And usually, if the video is prepared to be played, to be streamed in the internet, this index is in the first part of the file. So you can download that part. Then, after having that part, you can start your player. That's usually a few seconds. So if I go back, you will see at some point the name of the video appear here. So in that moment, it means that the index is ready to use. Sometimes the video is not prepared to be streamed in the internet. That means that the index is in the last part of the video. And that's really bad news, because then that means that you need to download the full file. I think it's really common that you go to a website with a video, you click play, and then you need to wait for the video to load, to start watching it. That means that the index is at the end. So what I did that time in Touch and Go is, okay, let's download the first part, check for the index. If the index is not there, you can check you can download the last part of the video, and then like a binary search until you find the index. And then once you have the index, you can start playing the video. Oh, sorry, it was in pause. So for me, that was quite important. And I think it has a few reasons. First is you are being friendly with the community, with the swarm. You are still watching your video, so you are doing what you are enjoying. And if you use the rare first and we are I don't know. I think the best example is like what's video on demand now. It's like this big company HBO. They were trying to play Game of Thrones, and one day, and the online version was crashing every day. Everyone was complaining in the internet because it was a centralized thing. For torrent, it's the other way around. If you have like 1 trillion of users, that's better for you. And then if your users are having a friendly configuration, then you will have availability for all the pieces for the whole video. So if I connect and then I disconnect, other users are going to have the other part. So here you can see that it's downloaded pieces from random places. That means that it's in rare first. But still the part that we are watching, that has more priority. So priority 7 here, or 3, 1. So you can fine tune the priority and still use the rare first. So you can be friendly with the community and still watch your video. That's at the end what we want to do. So that, I think that's the hardest part. So the streaming, about seems hard, but it's not so hard. So as I was saying, I think it would be a really good idea. Probably it's not easy to implement because, yes, I know maybe you need to pay for your videos because you need to pay to the actors, etc. But then, as I was saying, if you release a video in streaming in a BitTorrent and you have 1 trillion users, that's amazing because your video will have a really high availability. I don't know, maybe if the video is too big, we are going to break the internet, but that's not a problem. But how we solve that in our local client, in our personal torrent client? So you just need to have a HTTP server, and your file is in your disk, and you just need to say to this server, okay, please, I want to serve this file in a HTTP protocol, and then you start your player and you tell, okay, go to localhost this port, and you have a video here. In Python, you have the simple HTTP server. Probably, I would say, with new version of Python 3.8, probably I will go for async IO, but okay, this is all. And this screenshot, I think, is still Python 2. So I will push a branch that I did in the weekend that is working with Python 3. But the idea is there is with simple HTTP server, what I wanted to show here is that you only need to write the get function. And in that get function, you need to know which part of the video you need to provide to the player. And the player is telling you, so there is interaction there. And I'm not showing it here, but there is a lot of really, really interesting things to play when you are doing streaming. So if I will move back a bit to this screenshot, we were able to tweak the server so to be able to move forward in the video. So if you click in the middle of the video, then the player is going to request a different part of the file because the player knows it has the index for the file. So it will tell you, okay, I want this byte, this part. And then in your server, because the user is requesting that, the player is requesting that part, you can change the priority for those pieces to the highest one. So the user can play in the middle of the video on the player. You can change the priority, wait a few seconds, and it will start playing there because the priority for those pieces is going to be higher. So in Touch and Go, I remember we did some improvements there. I'm sure there is a lot more to do, and it was a lot of fun for me because it's like, I don't know, when you are using video and these things, it's nice that you can see what you are working on. Okay, then next step, subtitles. Yeah, so I watch usually watch TV shows using subtitles. So there is 2 libraries in Python: Subliminal, that is to download subtitles, and then guessit. Guessit, you can use it to get data, metadata from the file name, like season 1, episode 10. And then if you extract the data with guessit and you provide that to Subliminal, like in this example, then Subliminal has this download best subtitle, and that's all you need. It's like, give me the best subtitle for this video, and it will download and save the subtitle in the same path that your video, of course, with a different extension. So you will have in the same file path your video and your subtitle, and you already have a HTTP server serving the video there. So that's really cool. So then to finish, the only thing that you need is to put all the parts together. So I think a good example for that is Touch and Go. Sorry, a disclaimer, Touch and Go, I know in English has a meaning, but the name was quite as a joke in Spanish. So Touch and Go means like, you need to do the literal translation to understand what is meaning in Spanish. It's like a fast thing. It's like I touch and then I move to the next part. I think that was the idea. So in 2004, we did this project. It's in this GitHub repo. I'm going to push later a branch, Python 3 working, so you can test it and it's going to work. You only need to have VLC and etc. PP start touch and go. Not sure if that's going to work because it was Python 2. Yeah, I don't remember, to be honest. In that time we were using, I don't know, some libraries that are not working anymore. So you can use the branch I'm going to share later. And yeah, that's all. So for me, this is the most important slide of this talk. So the torrent technology is really, really nice. It's a lot of fun. You can learn a lot because there's different technologies. So I think that's really good. But for me, this talk is a really good example of the most important Python piece. So why Python is such a nice language is because the community. And as you can see, more than half of the work was already done. I just was like using glue to put all the parts together. And maybe, yes, learning and reading docs, but the most important part, so I didn't have to do a Python implementation of the BitTorrent protocol or a thing to download subtitles. So I didn't have to learn how to use the API for this weird website in the internet. So for me, this is a really nice example of why Python is so awesome. I think Hayley is going to talk probably about satellites. And I worked in the past in a satellite company. I was writing code that I was running in the space. I wrote a project to track satellites with Python. That software is running in satellites currently. And I did that. You know, I didn't finish the university. I don't have a degree. I'm not a mathematician or anything. And because of Python, it was possible for me to achieve that. So I think that's awesome. Okay, that was all. And I'm listening for questions now.
That was so cool. Thank you so much.
And 40 minutes, that was almost there.
I could not tell that was your first talk. You did amazingly. Thank you.
Thank you. Thank you for having me.
Now, anyone has questions, because I have a couple. If no one is coming forward. So Ben has a question there for you.
Yeah,
Nico.
so is there a guide?
Is there a guide for newbies on how to implement it?
So I can share my slides and you have the repo for Touch and Go. I think that would be good enough. Before we finish the meetup, I will share a branch with the Python 3 working version, so you can play with that. Disclaimer, that code is old, it doesn't have tests, so I don't like some parts, but it's easy to read, and I think that's a really good starting point.
Well, so if the newbie wants then to start doing some stuff on testing, that's a great opportunity for open sourcing, isn't it?
For sure. Yeah, and I'm happy to answer questions. You have my email and my Twitter. There, you can also find me with that handle, Gilgamesh, in Telegram or Freenode. So just ping me. I'm happy to help.
Do you want to have a Python sprint on it?
To be honest, this library is not maintained now, so I don't know. I want to have a Python sprint. So we were planning to have we were planning for PyCamp with some friends. Oh, this thing doesn't. I was trying to put our right here. Okay. I was planning to be next week in PyCamp. That is a Python event for developers to spend some days, 4 days hacking. And my idea was to work in the DHT protocol, so the decentralized hash table, because I have this crazy idea that we can have like a database in the swarm, and then you don't need a central server when you're sharing files. I would like to work on that. In Touch and Go, I think there is a lot of, it's nice to learn. Then there is a lot of issues because a lot of users are using this software to download illegal videos from the internet. So probably not the best project to be working on. You're going to receive some emails. So yeah. I don't want to keep working in this project, but I would like to work in some hacking things with DHT.
Cool, cool. So that's a project then. So I have a question for you. So you're talking about the Subliminal. Is that the name of the library that you're using for the perfect? So there is a line of code there that says, so downloading the best subtitle, right? So choosing the best subtitle to download it, to put it on the folder to implement it to your video. So what is the criteria for the best subtitle? Because like I used to download my subtitles for torrent like manually. I would just like take the name of the file and show it on the browser and see what comes back to me. But then I would have to test all of them, and most of them would be out of sync or wouldn't be that much of a great subtitle or something like that. So how does Subliminal actually test it?
Subliminal is just amazing. So Subliminal has a database. Sorry, it doesn't have a database. It knows how to talk with the subtitle websites, like Open Subtitles. I think that's the most popular. And then it knows how to send to this website all the metadata from your video, and it will find the best match with your file. And that's the reason why the other library, so guessit, this one, sorry, I know my keyboard is quite noisy. Guessit, that one is a really good match with Subliminal, because if you just put the name of the file, Subliminal is not going to give you a good result. But then guessit is getting all, the videos, they have this, there is a convention in the internet that you have the name of the TV show, season 2, episode 4, and there is some weird letters there. Guessit knows how to understand that part, and it will put that in a structured way. And then if you provide that information to Subliminal, it will find the subtitle that has the best match with your file. And how they do that, that's the Open Subtitle is doing that. So for each subtitle, they have metadata stored in the database. So and that's one of the providers. That's the one I know more. But there is, I don't know, in Spanish, you have a SubDivX, for example, that's really good for Spanish subtitles. So it depends, but then it's not the library. So the library knows how to talk with the API, but then in the website, you have a lot of metadata related. And it's really important to use guessit, because then you have, for me, my experience is like in the code, I call this function and then I get the first one. I don't check because I know it's going to be good. It's like a 99% of the time is good.
Okay, cool. Cool. Well, thank you. Thanks a million.
I have an alias in my computer, so sorry. So I have this alias in my computer that I used to download. So I'm sharing that. All panelists and attendees, yes. So I use that command in my shell to download a subtitle. So then I have that alias and I add sub space the name of the video, and Subliminal will download the subtitle for that video for you. So,
Okay. Yeah, I know. I was talking about fates today on MeetUp, so yeah, cool.
nice. Okay, thank you. Thank you. Thank you
Thank
for having me.
you. Thank you. Thank you. It was awesome. Wonderful. Now, I will put up the link for the lightning dogs for who is interested in giving a talk later on. And then, do you reckon we need a break, or shall we go straight to the track 2? How are you feeling, guys?
I think maybe a toilet break, because we have been sitting through already like 45 minutes. If you are drinking a lot, or if you have beer at home, I think it's time for you to go to the loo. And we can give like some time to another speaker to maybe check the tech and see if this sharing screen works and everything works. So yeah.
Perfect. So perfect. So I give you guys 3 minutes then. Run.
Yeah.
Wonderful. Perfect. So we're back at 10 to 8 then with Dr. Hayley Evers-King. Perfect. Wonderful. Now, Hayley, would you like to test your screen with me? Perfect. Thank you, Ben. Thank you. No problem at all. Take care. Perfect. I see everything. Wonderful.
Looks good. Can you hear me?
Yes, you sounds perfect.
Great. That's good. Nicholas, I'm sorry I missed the first part of your talk. It seemed really interesting though, so I feel like I'm going to have to go back and explore all the things you shared. So all very new to me, but very, very interesting. And very cool to hear that you've worked with satellites too.
We are looking forward to have you in the Amsterdam meetup, by the way.
Thank you. Where did you do your work with satellites? Which company or which organization?
I was working in Satellogic, that's an Argentinian startup.
Okay.
The startup is still there. So they are building microsatellites. So it's like a size of a dishwasher with a 1 meter per pixel resolution.
Wow, that's good.
And they also have a hyperspectral camera. I think that's going to be really interesting for you.
Yeah, no, definitely.
This hyperspectral is 30 meters per pixel, I think.
That's amazing.
Yeah, that's awesome. That's a really nice company, and they are doing an amazing job.
I must look them up.
And they are doing satellites in a really, really cheap way. You know, it's a big difference with the common industry there. So yeah, that was really cool.
Nicholas, do you want to have your project in the London Python sprints? So actually now it's become just Python sprints because we are not limited to London anymore. So I think it would be a cool project to work on. Like we can have it like in May, if you're happy with that.
No, I don't know. I don't know. I need to. I'm doing a lot, so I will need to think about that.
Okay, let me know anytime. Like if you want it, later in the year, I can also do that. Yeah.
Okay. Yeah. That sounds good.
Yeah.
Can you hear me now?
Yeah, Python sprints is a lot of fun. Like I went for the Terminus DB one, and it was actually quite cool because everyone is like together, just like coding and doing their own sprint, and then you go away, and then you come back, and there's beers. It's magical.
Yeah, I think we need a new project because like we don't have in April because I'm extremely busy, but want to have another one soon-ish. So yeah.
Cool. So
are
we all ready for track 2? Dun, dun, dun. I think we should start. Perfect. So we are back then with Dr. Hayley King, and we are going to talk about plankton polar orbiters and Python.
Shared right. There you go. Okay, thank you very much. And thank you for having me. This is the first time I've been involved in a Python-based meetup. So I'm very, very pleased to be here and to be able to share with sort of maybe a slightly different community than I normally talk to. So hi, I'm Hayley. I work for a organization called UMetsat. You may or may not have heard of us, but you will have certainly seen some of the work that we do probably every single day. So UMetsat is the European organization for the exploitation of meteorological satellites. So we run all the satellites that provide data for the weather reports and forecasts that you get every single day. That's one thing we do, but we also operate a variety of other satellites for different purposes. So not just weather, but also looking at climate. And in my case, which is why I'm here, we also operate satellites that look at our oceans. So in my background, I'm actually not really a space person. I'm a marine scientist by background. I've studied the ocean for the last 10 or so years. However, I now live miles and miles and miles away from the sea. I'm based in Darmstadt, which is pretty much straight in the middle of Germany. So I'm about as far from the sea as you can get. But I'm hoping to convince you with this talk that between a polar orbiting satellite and some Python, that you can also observe the sea from wherever you are in the world too. You don't actually have to be a scientist sat next to the sea or on a boat to study it. So everything in this talk most of it is through a program called Copernicus, which is from run by the European Commission, of which we take part as UMetsat. But space is really a team sport, and we work a lot with different partners, the European Space Agency, who I'm sure you've heard of, and various other partners all around the world to make these missions and data kind of products and services happen. So big thanks to all of them for the content that I've rather shamelessly stolen in this talk. Okay, so I wanted to start with this picture, which is not a picture from space, and it's a picture that still to me is a little bit absurd. So these creatures, if you've never seen them before, are plankton. Their name comes from an ancient Greek word which means to drift. And they are literally just a group of different species of creatures, some more plant-like and some more animal-like, that live in every single drop of seawater all around the world. And they're very, very important. They are the basis of our marine food web. So anything you eat from the sea has these guys involved at some point. They produce around about half of the oxygen that's in the air that we breathe. And they do a whole load of other things, but I'll tell you more about that in a minute. Anyway, so this is plankton. This is one of the things I've been studying a lot over the last 10 years. This is pretty much the same picture. You'll have to take my word for that. This is it is the same picture, but it's taken with a very different set of eyes, different set of instruments, and from very, very far away. So the image you see here is what we would call ocean color. It's a combination of measurements of different wavelengths of light measured by a satellite called Sentinel-3. There are two of them. The company I work for operates them. They fly around above our heads and they scan the Earth and collect images such as this. And the green swirls that you see in this picture are the impact that you get when you have enough plankton in the water to change the color. They actually change the color of the water all over the world. You've probably seen it with your own eyes. Some places you'll have been, the water's very, very clear, maybe somewhere nice in the tropics. If you've been down around the coast of Ireland or in the UK, you've probably seen it's much more green and murky. Phytoplankton are one of those things that live in the sea that change the color. And the reason they change the color is part of what it is that makes them so special. So they photosynthesize like plants on land, and they absorb light. And this interaction they have with the light field is what makes us able to observe them from space. So to me, it's completely absurd, this idea that these microscopic creatures that you can't see with your eye, you can actually really capture in this incredible way from space. So yeah, this image here is from Sentinel-3. It was taken last summer, just after the massive heat wave we had in Europe. There's particular species of plankton that are involved in this big bloom we see here are called cyanobacteria. And they typically proliferate when we have very warm conditions and the sea is very stable, allows them to grow and grow and grow and grow. They can cause problems. They accumulate near the coast. They can harm your lungs and things like that. So very interesting phenomena and very beautiful. I'm sure you'll agree. They're not always so beautiful. This is quite an interesting picture and case here. So this is the coast of Southern Africa. This is where I did my PhD. I studied at the University of Cape Town, which is just around the corner from where this photo was taken. The photo's from a helicopter, not from a satellite in this case, but we did actually look at this phenomena with satellites as well. And you can see that big red streak in the water there. And this is the same sort of phenomena as in the previous picture, where we have phytoplankton of a certain type that are causing the water to turn red. And these blooms that you get here, like this example, are very common along this coastline. And they represent a huge amount of growth in the water. And eventually these creatures run out of food to eat, and they all start dying off. And when that happens, they start decomposing. It's basically kind of like a compost heap, if you've ever been near a compost heap, and you get that really awful smell. It's from these different bacteria that are degrading everything that's there. It pulls all the oxygen out of the air around it, and in the water does the same thing. You end up then with these big swathes of the coastline that have nearly no oxygen in the shallow bits of the water. And the picture you can see inset here is when this has happened, and a whole coastline's worth of rock lobsters have just had to walk out onto the shore because they've got no oxygen left to breathe. These are an important fishery for this region. As you can see here, this gentleman's not letting them go to waste. So these phytoplankton also have these really quite bad impacts on our environment as well. In this case, what happens is totally natural. It's related to the ocean circulations in this area around Southern Africa, but it can happen as well as a result of influxes of things like fertilizer from the coastlines from our activities such as farming. So this is an animation, a collection of satellite data, and I wanted to sort of show you this just to give you an impression of how complex these systems are and how the changes in color vary with time. And this is 10 years or so of data, but also all around the world. You see very different activity going on in the coasts versus in the middle of the ocean. You can see the seasons quite clearly. I think when the Earth turns around, you'll start seeing the sort of seasonal cycle as we get light in the northern and southern hemispheres, respectively. There you can see it going up and down. And this really should just give you an impression of how complex the oceans are and how hard it is to observe them fully without this kind of picture. You imagine taking a boat out and trying to take a measurement at any point in this map. It would be impossible to have an idea of how dynamic it is in space and time without something like a satellite to capture that. So that's what we do. We use satellites. This one you can see here is again Sentinel-3, which is kind of my favorite one, I guess. It's the one that I work with the most in my job. And it scans the Earth, as you can see here. It measures the different colors of light that are being reflected back at it from the sunlight. So it can only work during the day and it can't see through clouds. And you can see that it captures all this information. It's what we call a polar orbiting satellite. So it goes around and around the Earth over the poles. And the reason we have it in this orbit is so that we can take advantage of its position to make the optimal measurements that we need the light for, and for various other things as well. You get different types of satellites. This is a polar orbiter, as I said, but you also get geostationary ones. These sit at a certain point and just stare at the whole Earth disk. We use these a lot for weather forecasting. There's one that we operate that sits above Africa, and you can use those satellites to take measurements much, much more regularly in time, but you can't cover the whole planet with them. So we trade off with the polar orbiters, and we have two of these ones that are in this particular animation, two Sentinel-3s, and they orbit all around the Earth, and they can cover the whole planet in about 2 days. So we get every point on Earth basically gets imaged every 2 days at least by these satellites. The further north you are, closer to the poles, the more frequently you get the measurements. So get a bit of benefit if you're in the northern hemisphere as we are, and the same in the southern hemisphere towards the poles. It's not just the color and images that we can measure with satellites. So we have a number of different ways of measuring different things about the ocean and land and the atmosphere as well, but I'm mostly talking about the ocean here. Three main areas that we work on, and these are all represented on the Sentinel-3 satellites that I work with, are altimetry, which is a form of radar, and then two optical types of measurements, so the ocean color, which you've just seen, and sea surface temperature. And the reason we make these measurements is this data can have a a huge number of applications that are really relevant for people all over the world. You can see in the diagram here just a few of some of the example applications. Some of them you may not be familiar with, but things like supporting fisheries, monitoring coral bleaching, understanding climate change, weather forecasting, making sure that our shipping is safe. You can see on the left there some examples of rogue waves, of ships that have had issues running into ice. We can monitor things like illegal fishing and oil spills as well. So the satellites really are a toolkit for addressing problems we have here on Earth, even though they're up in space. But we have a bit of a challenge. We have huge volumes of data, somewhere in the region of 50+ terabytes per year from sort of one of the Sentinel missions which we're running. At the moment, there's 4. There will be probably somewhere in the region of 15, I think, in the next sort of 5 to 10 years of the missions. And usually they're flown as multiples of satellites, so we get good coverage. So basically a huge amount of data. And on the right here, you can see the sorts of people who may need to use this data. And well, I'd invite you to think about how many of those people have the capability in terms of skill and infrastructure to be able to manage 50+ terabytes of data every year. I mean, I think Angela Merkel's doing a fairly good job at the moment with her particular profession, but I'm not sure how good her programming skills are or what sort of computer she has. So there's a big challenge in actually getting the data down to people who could benefit from the information it can provide. And in reality, there's a huge number of people that are involved in between. So this kind of summarizes just the diversity of people who work in the satellite, like Earth observation field. On the right-hand side, you have the people who are like me. We operate satellites, that's our job. At EUMETSAT, we don't launch them, we don't get the fancy rocket launches, we leave that to our colleagues at the European Space Agency. But once the satellites are up, we make sure they're operating day to day and we send the data out. That goes downstream to many expert users, people who work at universities and specific research facilities who have good experience working with Earth observation data, probably people like Nicolas and the company he was working for. And they work with this data to make sure it's accurate and to derive new and interesting information from it, and also to inform back up to us what we should be doing in terms of calibrating our instruments or new sensors that we should be developing. Moving downstream, they work particularly with experts in different fields, so maybe in the insurance industry, maybe marine biologists who can say what this information can tell them about the environments that they work in or the sectors that they work in. But still, that data is inordinately complicated and it's got to be communicated out at some point. And this is where sort of developing services and tools to view and analyze data is really, really important. And we're seeing a huge growth in the kind of number of experts from different disciplines, app developers, software developers, people working on WebGIS, etc., who are getting to grips with this data and helping to get it out to people downstream who can use it more. And at the end, we hope we have an impact on different sectors. So there you might have everybody from, there's a lady here on a beach, what she stood amongst is sargassum seaweed. This is something that occurs naturally in the oceans and floats around, but occasionally ends up on land and absolutely devastates the tourism industry in different places. Knowing that it's coming means that areas can put booms across bays. So one thing that remote sensing can do, or Earth observation from satellite, is say when this is coming and get people prepared so they don't wake up and find this on their beach in the morning. We also obviously contribute lots of things like policy. So the IPCC reports and various different pieces of environmental policy are increasingly becoming informed by the sorts of information that comes downstream through this process. So why Python? What does this have to do with Python at all? Well, Python really is a tool that is now embedded throughout that entire value chain that I just showed you, from the very top in organizations such as mine all the way down to the end users who may not be working with Python themselves, but they're certainly benefiting from tools that are based in Python based language and software, etc. So at the system level, the things that we do, operating the satellites, running the ground stations, processing the signals into meaningful information, runs with Python. When that data is produced, it needs to be managed in databases, it needs to be able to be searched. We use a lot of APIs, etc., and a lot of that is Python based too. Downstream scientists and various other users need to analyze data. Python is becoming an increasing tool amongst that community, although perhaps not as quickly as some of us might like in different parts. So this is something I'm working on at the moment. Data needs to be visualized in some way. These data, as I said, are huge, so you have to change them, summarize them in different ways, whether it's an image like the one behind me or in terms of some sort of time series graph or something like that. It has to be manipulated and visualized, and it needs to be communicated, and that's where that really comes to the fore in terms of app development and web developments, where our visualization, our data capacity meets, and Python is a really great tool for us there as well. The last point I think is very important here as well is that science that we're doing, especially in the Earth observation sector, is increasingly open. So I've mentioned the Copernicus program. This is the missions or program that I work on from the European Commission. And it has a very strong open data policy. So data is freely available for everybody all over the world for whatever purpose you like. You can go and download the data and use it, build a business off it. It's free and open. So I think naturally kind of Python and open source software and principles goes together with this very well. And it's a tool that we're using increasingly to help more people access our data and benefit from it. So it's really a tool that is used across this sector. I can't explain enough. I mean, there are people who are way, way more capable of Python than me, who are working, for example, in our systems and processing, but all the way down to the scientists and sort of new users are also using Python now more and more because there's so much available to support us in our work. So how am I using it now? Well, I am ashamedly, I guess, slightly an ex-MATLAB person. So this is what the oceanography community has historically used. That's what I was taught during my master's degree, and I hated it. It really sucked. I did not enjoy programming at all. It did not come naturally to me in the slightest. However, I'm pleased to say that's probably changed quite a lot now, and I actually really enjoy a lot of the programming I do since I've moved over to Python. I find it much more sort of intuitive to use and just a much wider range of possibilities. I worked in South Africa for some time, as I mentioned, and this really impressed upon me this need for open source. Data as well has gotten so much bigger that a single kind of limited technical programming language is not really sufficient for those of us working in Earth observation. There's a lot asked of us as scientists working in this field now. You know, we have to know more about things like working with databases and doing large, efficient processing, which is not something that was necessarily asked of scientists a long time ago, and we don't necessarily get trained in those sorts of skills as we go through our careers. I've spent the last part of my PhD reprocessing a 10-year archive of data to understand why these red tides that you saw in the previous picture, the harmful algal blooms, occur. And in order to do that, I needed to interface with a high-performance computing system, which I just could not use MATLAB for. Licensing would have been prohibitive, so I had to learn Python pretty quickly to try and get to grips with that. And the challenge I have now, which relates to the job that I do, which is very much interfacing between the organization I work for who operate and develop the satellites and the users downstream, is supporting the next generation of users and the people who will come and work in organizations such as ours. So we're really using Python a lot now as a training tool for scientists to help them work with our data. We rely a lot on various things like the NetCDF libraries. We use a lot of X-array. We work with a huge number of visualization and sort of image manipulation libraries, things like GDAL, CartoPy, various different mapping libraries and tools. We're also, as I said, because of this open data policy, really pushing to encourage our community to use and share more things openly. We're even down to things like the data that we use to double check the quality of our satellites. It's now as part of our standards that you have to provide the code you use to process your data, so other people can openly see it and review it so that we can ensure its quality. And you can't do that unless you've got something like Python that you can do that in. And also, I'm trying to do a lot more to let kind of expert programmers know about our sector. As I say, this is not something that is kind of my core skill. I used Python as a necessary tool. I'm definitely not a computer scientist, certainly not by training, but we need more people who have those skills in our sector. So I'm doing a lot to try and reach out to different data science communities to let them know that these are the sorts of fields they can work into. There's lots of cool Python related things going on in our sector at the moment. Myself and some colleagues recently had a chat. This was a week before last, and we've started gathering a whole bunch of different tools and libraries and code that people have been publishing on GitHub in this collection here that you can see at the link. This will soon be added to by a repository that I've been working on in UMetsat to share all our training code and tools and outcomes from our science studies. As part of Copernicus, we run a huge amount of hackathons and data visualization competitions. That link there is just one that you can check out if you'd be interested in working with our data and putting some of your Python skills to other use. I can really encourage people to do that. I always learn a lot from these hackathons because people come with very different ideas and experiences that I would not necessarily have thought about. So I would highly encourage you to have a think about that. The last thing is, if you're really interested in learning more about Earth observation data itself, we run training courses, as do many of our colleagues, and you can find out about some of them at the link there, the training.umetsat.info one. Most of them are focused from my side on the ocean, but we also do things on climate and on atmosphere and on weather. And a lot of these are openly available. There's funding available usually to come and join us if we're doing them in person. Obviously, with the situation we're all in at the moment, this is not something we're doing so much, so most things are online, but we are still going and still running training. So with that, I'll leave you with a very nice image taken last week of Ireland with Sentinel-3, and thank you very much for your time. I'm happy to take any questions, and you can contact me either through this email or on my Twitter as well. Thank you.
Thank you. That was amazing. I love the picture, by the way. The picture is, it's so cool. Cool. So does anyone have questions, guys? All the questions that came up to my mind, you actually gave the answer straight away. So yeah, just take that as a really well done job.
Thank you. Thank you. I'm glad you enjoyed it.
How does the training work? Like, do you guys do like, do people sign up for it and then you do like small courses, or you do by tasks? How does that training work?
Yeah, so we run various different things. The main courses we do sort of twice a year are blended courses, we call them. So we have an online phase where we use a platform called Moodle, which just serves as like kind of a front end really. You can go through then read about the satellites, about the data and how it works, you know, from a scientific perspective, about what formats it's in. We also help, it has videos, it has interactive tutorials and things like that. We help people to register to use the data. We show them the basics. A lot of people come to our courses and have never done any programming. So we have this challenge quite often of getting them to start with Python, which is a challenge I really enjoy, because I think a lot of people can be a bit nervous or a bit put off by it, think, oh, that's not something for me. But we usually get people running code quite well by the end of the course. So that the online phase sets them up for that. And then we have these classroom phases, which are typically a week, where everybody comes together. And we are quite unusual in that we don't do anything like traditionally in terms of lectures and things like that. We very rarely stand up in front of a PowerPoint and talk. It's all interactive, and we get people to kind of self-define a project they want to work on, and then we help them. A lot of this is based around a code repository that we share, which has lots of examples of how you can download data in batches, how you can visualize it, how you can make it interact with other bits of software to derive other information and things like that. And then by the end of the week, we have people present back to us something they've investigated. And that can be anything. We've had people who've done oil spill detection, who've looked at building a system that would regularly get sea surface temperature data to stream to little information centers around beaches in the this was in the Baltic Sea area. We've had people look at whether they can use this information to help define where they should put marine protected areas, or where they should guide fishermen to go to minimize their fuel costs. All sorts of different projects. You know, some people just work on very data heavy processes, so they do things like large scale visualization or incorporation into web portals, or about managing their own archive if they work for like a big data center, like one of these national data agencies or something. So it's really a very diverse range of people who come to our courses, and I like that, because we bring people together from these different backgrounds as well for them to exchange ideas. So they're open applications, so anybody can apply. You have to write a motivation. Yeah, it's pretty open in that sense too.
Wonderful. Well, so that's a chance then for everyone that enjoyed Hayley's talk. You can join her as soon as this is all over. We can all join.
I have a question. I don't know if I'm cheating because I have the microphone, but then I will take advantage of that.
Go ahead. Go ahead.
First, cheers. So I'm trying to have the meetup feeling, so I'm having some.
Oh no,
wine.
I should have got some wine. I've only got water.
Yeah, I have water as well.
I was using water, but then do you have any open set of images that we can play with?
Yeah, I mean you can literally access all the data that we've collected from these satellites since they were launched. So I can, if you go to here, let me write it in the thing for you.
I already knew the answer, but I was cheating.
Yeah.
but
no, it's a good point.
I think that's really cool because the Sentinel data is quite big.
Yeah. So this is just one example. This is the delivery, like the main delivery mechanism that we use for our data. It works. This is where you'd find the Sentinel-3 data, mostly marine stuff. As of today, there's also been, we've released some new products on looking at fires, which is quite interesting. So this you can access. You can use an API as well to access it. Yeah, that's just one. I mean, there's lots and lots of other different portals you can access this data to through as well. There's a really, really great one called Sentinel Hub, or you may have heard of EO Browser. That is it's by a company called Synergize. They have a really, really fantastic interface. If you don't want to do too much programming, but you just want to look at the images, that's also great. It has quite an interactive code-based backend though, so you can use it to do quite complex stuff. It's very cool. We've also been recently involved in launching a hosted processing system. So we are putting all this data into one kind of distributed hosted processing infrastructure, which will hopefully help people to access it more readily without having to download it all, because it's so big now that it's pretty impossible to hold it all yourself. So yeah.
Oh, cool. So we have a question here from Georgios asking, what type of libraries do you use for the visualization of data?
Hang on a minute. Where are we? Is this in the chat? I was just trying to see what was it they said?
That's in the Q&A. That's the Q&A. Yes.
Library visualization of data. Yeah, so most of my stuff I use Cart2Py at the moment. That's the one that I use. I mean, it's basically Matplotlib in background, but I use that extensively because of the mapping functionality. It's pretty useful for us. But I'm always open to other ones if people have suggestions, because this is something that I kind of use one thing and then end up using that for a long time. But then new things come along. We used to use the kind of Matplotlib and base map combination, and base map we stuck with until it basically wasn't supported anymore, and then we've been forced to move to Cart2Py. We're not a very rapidly advancing kind of population, I guess, in science. Sometimes we tend to, we get something nailed down and we stick with it, which is bad. We should be better at that. So yeah, if anyone has suggestions for good visualization, I'd be very keen to hear them.
Perfect. I think someone is suggesting something on the chat right now.
Okay. Oh yeah, Rasteria we have used. Yeah, I have used it before. It's good. It's good. Yeah.
Perfect. And then I think Agatha is asking if we could send you the links of the services that you just mentioned. They are on your slides presentation, aren't they?
Yeah, there's some of them are on there. The data services aren't, but I can add them if you want. I'll add some more information on where to get actually access to the data and things as well. That's no problem.
Perfect. And then we share the slides with the presentation.
I think you're missing a question there.
Whereabouts? Oh yeah, the cyclones one.
Yeah, that's a really interesting question. So, I mean, we don't sort of annotate the data explicitly in terms of, this is a cyclone, or this is, a specific one. But we do flag our data with kind of various indicators. So, I mean, you have flags, for example, for different types of cloud, which could be useful in this kind of circumstance. I know quite a few people who've done some really interesting work on doing pattern recognition with the data to try and pick out things more regularly It's something I did myself, not with cyclones, but with the blooms that I showed in the presentation. We were trying to identify them as kind of like a blob in their own right, and then track where they go, because the movement had quite a lot of use for the fishing industries and the aquaculture to say where they were going to go and predict their movements. So that kind of image analysis, and there's a lot of work going on with machine learning to try and identify things more. It's not something we do routinely commonly at the moment, but I feel like that's the way that the sector might go. You might find that we do more of this kind of analysis, ready data, using machine learning AI techniques to identify features. It's a great question.
That was a great answer. Thank you. Perfect. So I don't think we have any more questions for now. Well, thank you very much, Hayley. That was very, very, very interesting. Thank you. And then, well, I think it's time for lightning talks now, but I let you guys go for maybe a toilet break again, or some water. Go stretch your legs.
Yeah,
We'll be back at 8:25.
Yeah, so if you are giving a lightning talk, if you could raise your hand, then I know that I have to let you in to be speaking. So yeah.
So far, we only have you, Chuck, giving us a lightning talk. Can you believe that?
I could give more than one lightning talk, but don't let me, dominate the lightning talk. We need more people to give lightning talk. So this is your last chance to do it. You can still sign up. Thank you very much. Yeah.
Thank you, Elizabeth. Thank you for staying with us for so long. Thank you very much. I hope you enjoyed it. And if anyone would like to submit a lightning talk, that's the link again.
Oh, I'm sorry, my computer, my Zoom crashed. So.
Yes, fine. Welcome back.
Perfect. So we are back now. We are having lightning talks. Yes, absolutely. Would you like to submit one? Yeah, cool. So okay, no, that's a no. Well, anyone else, please? Come on, lightning talks are so much fun, guys. Come on, just join us.
It's two talks in one meetup is too much for me. Sorry.
Oh, really? You're spending your English and then you're not gonna get it back? Is that it?
This would be my third of the day, so I think it's one is enough for me too. I just came straight from another live stream, which was great. But yes, it's a lot in one evening.
Nice. Yeah.
Happy Earth Day.
Yeah, it's Earth Day. That's why I was doing the live stream.
Ooh, cool.
Yeah, it was good fun.
Cool. Yeah.
It was good.
Yeah, you told me earlier. I was actually cheating because you told me earlier on Twitter. I was like, oh, okay. So yes, but I just thought it was a good tone to wish you happy Earth Day. And Nico, you're gonna say something? Sorry.
No, sorry, I was.
No.
Okay. Let me know when you want to get started. I can just I don't have slides. I would just show some websites, and that's me. So if
Perfect. So whenever you wanna start, then I think we can, because
right.
yeah, because we don't have any more submissions. So it's
Alrighty. Okay, just let me go to that website and we can get started. Sorry. Yeah, if you can still submit, like if like when I finish, so you can just pop in. Like just let me know. Raise your hand if you want to give a presentation. I'll just let you in. Right. Oh my god! Like all my previews are gone for some reason. Zoom is just going weird at the moment. Okay, I don't know which one to share. I'll just share my entire screen. Share. God. Yeah, sorry, my Zoom is super weird today. Why do I want to share another camera? This is so weird. I'll just click on. Oh, I know why. Because my computer lock Zoom for sharing thing. Sorry, technical difficulties. Give me 1 second to fix it. Because I'm using the newest. By the way, I'm using the newest Mac OS, and oh, I have to quit and come back again. Okay, I won't show the my screen then. Sorry about that. So yeah, I'm using the newest Mac OS, and then they have these security issues, which I think is nice to stop the app to go to access your screen, but the setting is a bit finicky. So anyway, I just want to give a shout out to. I will share the link in the chat instead. There is actually a free data science beginners workshop in Python that is virtually online, that we are now looking for mentor and mentee. So this is the link. So it actually originally it was a PyCon hatchery program. So it was supposed to be happening in PyCon in Pittsburgh, but because it's cancelled, so now we are here at home rather than in Pittsburgh. So, but we will still run this program. We will run it over. Actually, it will be 2 sessions because it will be 3.5 plus 3.5. It will be like 2 Saturdays. So it's not, we won't blow people's mind and attention. We just like it's a very easy workshop. We will try to assign mentor with a small group of mentees. So a mentee. So if you have been to, or what is the Jungle Girl workshop, so it will be very similar to that, except that we will be teaching data science from scratch. We also cover very basic Python topics. So if you are a Python beginner, or if you have friends that they want to start learning Python to do some data science stuff, you are super welcome to join. But there's a catch. We will give priority for people who identify in the minority group. So make sure that if your friend is identified, as a minority in the tech community, make sure that they kind of explain to us, so we would consider them having a priority. So please share, and spread the word. And before you go, I want to also make an advertisement for another hatchery program that is mentored Sprint. If I can spell it, then I would find it. I can't find it for some reason because I put the space there. Yes, okay. Yeah, it should be in the hatchery program. So yeah, mentor Sprint for diversity beginners. So again, so I will share another second link. So again, it's a hatchery program, and it's also minority focused, but instead of learning data science, this one will be a sprint. So we'll work on open source projects. So in case you don't know what is a sprint, it's just that there will be sessions that maintainers of different projects will be taking some issues that we will work to, is work on at the time, and we'll work together. And it's very because we would have maintainers from a lot of popular libraries, including Jupyter or even CPython. if you want to, contribute to Python itself, that's your chance. Otherwise, it's super difficult to do it because it's such a, it's a big thing that is without help, it's actually quite difficult to get started. So that's the time you can get help from someone in a project. To help you. So I learned a lot from the sprints. I would say that like not last year because of my work, I was quite difficult to stay on this like for the sprint, but the year before I spent a lot of time in the sprints after the conference. So I learned so much in Python, and to work on CPython, maybe, I don't know, like it depends on whether we have someone from CPython to, if you want to be a mentor, then we can work on CPython, Stefan. So like that's the chance for you to learn a lot of Python with a lot of senior people. So and if you are identify as a minority group, then please let us know in the form, and we would definitely make sure that you're comfortable and welcomed in the activity. So that's the 2 announcements that I want to make, and so yeah, that's my lightning talk. I've hijacked it for announcements, so yeah.
Cool. You still have 1 minute and 2 seconds.
Okay, good. I'm not overrun.
Oh, thank you, Olga. Thank you. Thank you very much for being here with us. Thank you very much, guys. It was a very, very, very awesome remote Python episode. See you next time. Well, so yes, I think that's us then. If there's no more lightning talks, as it seems like there isn't. Thank you very much, Chuck, for hosting. Thank you very much, Terminus DB. Thank you very much, my lovely speakers. Thank you. Thank you for the great talks, and thank you for being here with us as well. Thank you for everyone that joined us and enjoyed the talks. Thanks for all the questions. Thank you for all the community love. Thank you very much, guys.
Thank you. Thank you for organizing.
I guess.
Thanks all.
Yeah, thank you so much. And we always love to host meetups because we love the Python community, and we love Python Island. I think is we say on the tweet, that because we are like a Dublin-based company, so we love your.
Perfect. Yeah,
we love you too, guys.
I'm looking forward to being in Ireland in the Dublin meetup in your life. So maybe next year.
We have a beer here saved with your name on it. Don't you worry. And the same to you, Hayley.
Oh, I'd love to come. That would be amazing.
Sure, so it's a date then. November. We're all here.
Thank
you, guys.
Thanks. Bye.